Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the third practice video that CollegeBoard uploaded in preparation for the distance learning AP exam. The question reads, the graph of f prime, the derivative of a differentiable function f, consists of 5 linear segments and a semicircle and is shown in the figure above. The functions f and f prime are defined on the closed interval from -5 to 10, and it is known that f of 6 equals -1. In part A, they are asking us to find the minimum value of f on the closed interval from -5 to 10, and we have to justify our answer. So before I figure out the minimum value of f, I should probably come up with a function that I can use to evaluate f at any place. So in order to do that, I'm going to say I'm going to create the integral from 6 to x of f prime of t dt. Using the first fundamental theorem, that's going to get me f of x minus f of 6. We know that f of 6 is -1, so I get f of x plus 1. So what that tells me is then that f of x, if I get him by itself, is equal to -1 plus the integral from 6 to x of f prime of t dt. Okay, let's go ahead and use this now to find out some absolute extrema. Now, this part A took a long time to do, and so just it's okay. If you find yourself, burning up time on part A, just move on to the parts that you can move through pretty quickly. So, before we do any kind of absolute min and max calculation, we should consider our candidates for the absolute min and max. Candidates for the absolute min and max are going to be, in this case, just absolute min, because that's what they want. Our candidates for the absolute min will be x equals -5, 6, and 10. We can actually, so we can exclude the other ones like x equals 0, 4, because x equals 0 is a local max because f prime goes positive to negative, and x equals 4, f prime does not change sign. And you probably want to specify that, otherwise you end up having to integrate everything, and it's just kind of a mess. So you don't want to do that. Integrating this on its own is actually already going to be pretty painful. So let's go ahead and find out where we're at here. So let's find out f of -5, f of 6, actually I'm going to do these one at a time, so f of -5, let's find that out. F of -5, well, that's going to be -1 plus the integral from 6 to -5 of f of t dt, or f prime of t dt. So if I flip the limits of integration, that's going to be -1 minus the integral from -5 to 6 of f prime of t dt. And so what you get is you end up getting -1 minus some large amount of stuff. So what is the integral from -5 to 6? Well, from -5 to 0, we've got a triangle. So that's going to be 1/2 base times height. So 1/2 base times height. And the base is 5, and the height is 3. And then I'm going to go and subtract a semicircle that's underneath. So that's going to be minus 1/2 pi r squared, so 1/2 pi. And then r squared is going to be 2 squared. And then I'm also going to subtract a triangle that is underneath. So that's, again, 1/2 base times height, right? So 1/2 base times height. And the base is 2, and the height is -2. So the base is 2, and the height is -2. And after doing all this simplification here, you end up getting -1 minus, looks like 15 over 2 minus 2 pi, looks like plus 2. So that's going to be 7.5 plus 2 is 9.5, so 9.5 minus 2 pi. And if you needed to use a calculator on it, you could, but it would be 9.5 minus 2 pi. All of that being subtracted from -1. All right, so I'll go and leave him right here because I feel like that might be good enough for us to be able to tell where he's at. Okay, let's go and find out what f of 6 is. f of 6. Well, that's going to be the integral from 6 to 6 of f prime of t dt. We don't even need to do this because they told us in the problem that f of 6 was negative 1 to begin with, so we're good there. And now I'm going to have to clean up the board a little bit, so I apologize. Give me a second here. And we are back. Let's go ahead and find out what f of 10 is. Well, f of 10 is going to be negative 1 plus the integral from 6 to 10 of f prime of t dt. Well, what is the integral from 6 to 10 of f prime of t dt? Well, that's going to be this triangle here on the right side. So that's going to be negative 1 plus a positive triangle. So negative 1 plus 1/2 base times height. Let's see, the base is 4 and the height is 2. So I end up getting negative 1 plus 4. So I end up getting positive 3. And then from here, you can then conclude that f will have an absolute max value of, it looks like this is the winner right here. I'm going to go ahead and just switch modes here. Looks like this guy's the winner right here. He's the most negative out of all of them. So I would say negative 1 minus 9.5 plus 2 pi. So again, if I wanted to combine that out, that'd be negative 10.5 plus 2 pi. When x equals negative 5. So again, pretty time-consuming for part A. So again, just keep that in mind. You know, that was a pretty time-consuming problem. Let me clean up the board, and I'll be back with part B. And now we're back with part B. It's asking us to find g prime of 6 if g of x is equal to the sine function. So before I find g prime of 6, I should probably find g prime of x, and that's going to be cosine of 3 minus f prime of x times negative f double prime of x. So our good old buddy chain rule makes this triumphant return. So now g prime of 6 is going to be cos of 3 minus f prime of 6, whoops, that's a sloppy 6, times negative f double prime of 6. Okay, so let's evaluate what these things are. What is f prime of 6? Well, f prime of 6 crosses the x-axis, right on the x-axis. So I believe this guy is 0. What is f double prime of 6? Well, f double prime of 6 is the slope right here. And so the slope right there is going to be, the slope's value is going to be 2. Because you go up 2 to the right by 1. So the slope's value is 2. So that's going to be negative 2. And so I believe the answer is going to be negative 2 cosine of whatever 3 is. Whatever cosine of 3 is. So pretty straightforward part B right there, I'm hoping. Alright, part C. Part C says, let h of x be the particular solution to the differential equation, dy over dx equals that thing. So dy over dx equals y minus f prime of x over x, and they tell me that h of 5 is equal to 6. Using Euler's method, starting at x equals 5, 2 steps of equal size to get to h of 3. So we actually have never seen this before, where we have to use Euler's method backwards. So from here, I'm going to go ahead and call this x, y, dy over dx, and then new y. Now, when it comes to new y, as always, guys, new y is always dy over dx times delta x plus old y. So from here, when you move backwards, it's the same as moving forward, except you're moving backwards. So instead of going 3 to 5, I'm going to go 5, 4, and then 3. What that does is it makes delta x equal to negative 1. And so realistically, when you're moving backwards on Euler's method, all you do is you change your delta x to something negative, and then that will take care of everything else. So from here, we just have to plug stuff in and treat Euler's method the way it always has been. So h of 5 is 6. dy over dx, this is a little bit hard to figure out, but it's y, right? So that's going to be 6 minus f prime of 5. Well, what is f prime of 5? F prime of 5 is negative 2. So that's going to be 6 minus negative 2 over whatever the x was at that time. So that's going to be 5. So that gives me 8 over 5. New y is going to be 8/5 times delta x, which is negative 1, plus old y. And so from here, if I combine all my like terms, I end up getting 22 over 5 as my new y. And then from here, dy dx is going to be the same thing. You end up getting 22 over 20 by plugging all the stuff in. And then you get 22 over 20 times negative 1 plus old y, which is 22 over 5. And that is where I would leave the problem. I would say h of 3 is equal to negative 22 over 20 plus 22 over 5. And I would just leave it like that. Okay. Let's clean up the board a little bit and we'll move on to parts D and E. Part D reads, for 0 to 10 seconds, a particle moves along the horizontal axis with a velocity v measured in meters per second, where v of t is equal to f prime of t, and t is measured in seconds. It wants us to evaluate the integral from 0 to 10 of the absolute value of v of t dt. And using correct units, we have to explain the meaning of the value in the context of the problem. Okay, so from here, this is like saying the integral from 0 to 10 of the absolute value of f prime of t dt. Now remember, an absolute value on the outside of the function, anything that is underneath the x-axis becomes overneath the x-axis. So all of those negative guys become positivized. So that half circle that was originally under, he's really over now. So I'm going to say 1/2 pi times r squared. And again, he's not negative because he's no longer underneath the x-axis. So then I'm going to say plus the triangle, which again is no longer underneath the x-axis. 1/2 pi, 1/2 base times height. And then the top triangle, he'll stay exactly where he is. So 1/2 base times height right there. And again, you can go and leave this thing unsimplified. And if you're going to explain this in the context of the problem, then all you have to say is, and we've seen this expression before, the absolute value, the integral of the absolute value of velocity, we know what that is. That's the total distance traveled. So you could say the total distance traveled by the particle is this number again, meters on 0 to 10 seconds. And I will go ahead and just copy that thing down one more time because this is our answer. Boom. And I believe that is how you handle part D. Should be pretty fast. Okay, part E is a little bit of a bear, so I'm going to clean up the board yet again, and we are going to come back to this one. Now that the board is all cleaned up, let's go ahead and write down. And whenever I do a Taylor, question, I always write down my generic Taylor polynomial first. So I'm going to say, all right, well, t of x right here, right? We're on E. T of x is equal to k of 6 plus k prime of 6 times x minus 6 plus k double prime of 6 times x minus 6 squared over 2 factorial. And I'm only writing the third degree, so I'm going to go ahead and just stop at my third derivative here, x minus 6 cubed over 3 factorial. So it's time for us to figure out what these terms actually are. Well, from here, remember, if k of x is equal to this integral right here, then we should find out what k of 6 is. Well, the integral is going to go away because the limits of integration are going to be from 6 to 6. So that means k of 6 equals 12. So that's good. I can go ahead and figure that part out right there. I'll plug those things in when I'm done. Well, k prime of x, right, is going to be using the second fundamental theorem of calculus, where we get 2 minus f of x. And if I want k prime of 6, well, that's going to be 2 minus f of 6. Well, what is f of 6? F of 6 is negative 1. So we get 2 minus negative 1, so I end up getting 3. So again, that's going to go inside my k prime right here. So k prime of 6 is equal to 3. I'll box them too, just so I feel like it. All right, let's keep on going down. So k double prime of x is going to be negative f prime of x. So k double prime of 6 is going to be negative f prime of 6. Well, what is f prime of 6? F prime of 6 is 0. It crosses the x-axis right there. So what I get is 0 or negative 0, which, whatever. So that's 0. Cool. So this k double prime is completely gone. I like that. K triple prime of x is going to be negative f double prime of, not 6, but x. X. Well, again, f double prime is the slope at that moment in time. Well, what is the slope of the line right here? Well, the slope is 2. That means that k triple prime of 6 is equal to negative f double prime of 6, meaning negative 2. So now we just got to plug those things in, and then we're done. So I'm going to switch colors here real quick. The k of 6 becomes a 12. I get a plus 3x minus 6. This guy is gone. And then minus 2x minus 6 cubed over 3 factorial. And there you have it. There is your free response question. Let's see where we clocked in at. We clocked in just over 15 minutes, and I believe that this was the 15-minute version. But we had to stop and explain some stuff. But overall, I think we made pretty good time on that, despite that nasty part A. And I think that will end it for these AP review videos for the YouTube College Board AP exam. As always, please leave questions or comments in the comments section, and we will see you in the next episode.